After seeing image, real image and virtual image, we will see how image is formed by the lenses. The ray diagram have been drawn using 2 out of 3 spatial rays. We have already studied the 3 spatial rays, and we will use 2 spatial rays to form images. Spatial ray mentioned above, the characteristic of image formed have been written along and the corresponding ray diagram. So see, when we will keep the object different position, object image will be formed at different position. So firstly, when the object kept as infinity, the rays coming parallel to the principal axis, it will meet at focus after refraction. We have already studied. So this is the meeting point, or this is the intersecting point. So this, at this point, image will be formed. We have to write characteristic of image. In characteristic, we will write position, size and nature of the image. Position at focus, size extremely small, nature real and inverted. You have already studied real images. Real image formed by real intersection, and virtual image virtual intersection, means there is no actual intersection. Inverted, downward from principal axis, erect, upward from principal axis. See next case, when the object kept beyond center of curvature. This is the lens and this is center of curvature, this is beyond the center of curvature. We have kept the image at this place. AB is the object. Rays coming from principal axis pass through focus after refraction, as we are seeing in the picture. Rays passing through optical center, it will pass undividedly. At this point, both rays will intersect, and this is the image, that is A dash B dash is the image. So this is the position of image. So what is the characteristic? Position between F2 and C2, size smaller than the object, nature real and inverted. Here real intersection is taking place to real image and downward from the principal axis, so inverted. Now when the object kept at center of curvature, this is the center of curvature, object kept at center of curvature. We will use 2 rules out of 3. The rays coming parallel to the principal axis refract and passes through focus. The rays which passing through the optical center will pass undividedly. So this is the place of intersection. Means position at C2, size same size of the object, and nature real and inverted. Next one, when the object kept between C and F. This is C and this is F. Object is AB. Rays coming parallel to the principal axis pass through focus after refraction. Rays passes through optical center will pass undividedly. So it will form between C, beyond C, FC, and this is the image, that is A dash B dash is the image. So it will form beyond C. So what is the position? Beyond C. What is the size? Larger than the object, and nature real and inverted. Next one, when the object is at focus, this is the focus point, object kept is at focus, using 2 rays, rays parallel to the principal axis will pass through the focus, that is rays object kept at principal focus 1, this is principal focus 2. So rays after refraction, rays coming parallel to the principal axis, after refraction it will pass through the focus. Rays which will pass through the optical center, it will pass undividedly. So these both rays are parallel, means the position of image will be at infinity, size larger than the object, and nature real and inverted. Last one, when object between F and O, this is F, this is O, this is the object, AB is the object. Using 2 rules, this is F1, this is F2. When object kept at between O and F, that is optical center and focus, rays coming parallel to the principal axis, it will pass through focus after refraction. Rays through optical center, it will pass undividedly. When we produce both the rays, it appears to be meet at this point, that is between C and F. Yes, this is position will be between C and F, between C and F, or C1 and F1. An object between F1 right? Size larger, very large, very large. Nature erect, this image will be erect, means this is upward, this image is upward from the principal axis, so this is virtual and erect. Actually the intersection is not taking place, so image will be from virtual. This is the only case when convex lens form virtual and erect image. Now image formation by concave lens. Concave lens, in case of when object is infinity, it will form image at focus, but in another case, that is when object is anywhere between optical center and infinity, image will form between O and F. We will see one by one. When the object is infinity, rays coming parallel to the principal axis, it will diverge, that is deviate. But when we produce backward, it appears to be meet at focus. So this is the lens which forms virtual images, virtual and erect image. Position at focus, size extremely small, nature virtual and erect, Second case, when object is kept beyond 2f, image is between f and o. When object is between c1 and 2f1, position between f and o. Nature virtual and erect, size smaller than the object. When object is 2f and c, 2f, image is f and o. When object is 2f and f, image between f and o. Position, that is between f and o. Nature smaller, size smaller, nature virtual and erect, In case of when object is between 2f and f, position between f and o, size smaller, nature virtual and erect. Next, when image is at f, position between f and o, smaller than the object, virtual and erect. When object is f and o, at f, when object is at f, position between f and o, size smaller than the object, nature virtual and erect. When object is between f and o, position f and o, size smaller than the object, image virtual and erect. Means we are seeing that when object is kept at any place in front of concave lens except infinity, when object will kept at infinity, image will be formed at focus, but except infinity, when object is kept anywhere in front of concave lens, it will form image between f and o, that is between focus and optical center, and size of image is always smaller, nature of image is virtual and erect. Now see application of lenses. This is the last topic of this chapter. So application, there are so many application of lenses in our daily life. We use spectacles, so many of the students using spectacles, so many of people using spectacle. So lenses are used in spectacle, in microscope, in telescope, in projectors, in camera. There are so many application of lenses. Lenses find a number of uses and application in our daily life. These are used in magnifying glass, telescope, microscope, photographic camera and spectacle, etc. So this was the end of the chapter. I explained everything very clearly. If you have any confusion, watch the video again and again, and if you have any problem in any topic, comment on this video. And now I will prepare video for chapter friction. So stay tuned and thank you.